Okay, today I'm going to talk about SDL2 audio and coming from SDL1 background. In SDL1, you opened up an audio device, but you didn't really have the ability to ask which one you wanted to open. You knew that you were going to play some music somewhere. Hopefully, it was going to come out of the PC's, speakers, but you didn't have that option. In SDL2, you have the option. You can open up audio devices and you can query what audio devices are available to you. Not only can you query the output devices, you can also query input devices for recording. Although the recording support is not fully integrated into SDL2 yet. I'm verifying that right now. Let me just type in audio. I think it's going to say it's somewhere around here. No, it's going to be in the open. Open audio device. So you could specify the device to be opened for recording, but I'm looking for that note that says how this hasn't been implemented yet. So yeah, right here, SDL2 does not support recording yet. This will fail if isCapture is non-zero. So just heads up, recording is not implemented yet. But basically, what I've done in my own application is I've taken the code I used to use, which would just open up an audio output device, all automatic. But now what I'm doing, and this is what I'm going to teach you how to do, is how to look at what audio output devices are available to you and how to open one and what functions you'll be using instead of the old ones to do things like pause it and resume it and stop it. And also something that I've added in my application is storing the device name into a file so that next time we open the application it'll automatically open our preferred output device, provided that's available, which I'm not even sure if I fully implemented that. I need to implement that. But one step at a time here, everybody. So back in SDL1, honestly, the wiki. I mean, you want to check out this wiki, man. You can go to API by category. There's an audio section, and you can learn everything without me just by looking at these functions. But the old open audio is still implemented in SDL2. You don't get that added flexibility of being able to work with other output devices. So the first thing you want to do is in SDL1 you call it open audio, but now you want to eventually call open audio device. But before you do that, we got to see what devices are available to us, and for that, let me go. I have an audio class special for this, and I recommend you make a special audio, if you're doing it in C++ at least. But do it whatever way you want. This is what I do. I prepare a char double star pointer called device strings, and this is where I'm going to store every output device that's available. I recommend you actually be more specific than I was. You should actually say output device strings, and then later we can do input device strings. Another thing you're going to want is SDL audio device ID variable, and we'll get into that later. I'm not too sure about the other stuff. I mean, I have an int for how many devices are there. But we really want to get to the query function, so let's go to the query function. In the query function, I assign that how many variable to from this function sdl get num audio devices, and we need to specify that we want playback devices and not recording devices. And I'm sure this function will fail if we say recording. Maybe. Let's check. So yeah, it just says this capture should always be 0. So I made a little enum for that, so I can just say playback device type, but you would probably say, I think it's 0. Yeah, for playback. And then basically, once I know how many devices that there are, I can, that char double star, I can actually allocate enough memory for that many, char stars that I'm going to be pointing to. And then I iterate through the number of devices, and I get the audio device name. And again, 0 is for, what's the 0 for? Probably playback, but I'm going to make sure. Get audio device name. Yeah, I was right about that. So really what this should say is this, to be nice and consistent. And once I get the name, I print it, I just print it out, and then in my device strings, my little double char star pointer, I actually allocate memory for this string, and then I copy it from this, because this is just a temporary variable that only lasts with the scope of the call to this function. You don't want to rely on that pointer there, so we copy it and all that good stuff. And since I have all this malloc going on, and then the destructor for this class, I go ahead and I free that stuff. I free it. Alright, now just to summarize what we've just done, we have a little class here for audio devices, and now we know how many output devices we have, and we have an array of char stars for every single device, so we have all the device names. And we haven't done anything with the ID yet, and we haven't done anything with the selected audio out dev. Now let's look at how this stuff gets propagated. Remember, we haven't opened anything up yet. We're about to open stuff up. Nothing gets opened. Gets opened in this other class. Probably in the init. For an init. For an init function. No. Alright, let's look for audio. Alright, here we go. This is in sound init. I'm totally fine with that. Just like in SDL1, you need to set up an SDL audio spec structure, and you want to declare two. You want this one that I call AS here for short, for audio spec, is what I want to get, and then have is going to get sent to the function, and it's going to end. What have will be is what we actually have. What SDL gives us to use, and then we can furthermore, check the have variable to see if we have things that are different from what we asked for. But it's just like SDL1, and if you're doing this for the first time and you happen to be watching my video and you never came from an SDL1 background, I'll walk you through it. I mean, basically you have to set up a sample rate, which for me would be something like 32,000 hertz. You have another popular one, 44,100 hertz, and then the format of your samples. In my case, it's going to be signed 16-bit samples, because I have a Super Nintendo guy going in with signed 16-bit samples. Channels, I'm doing stereo, so I have 2 channels, and then a callback that's going to go to a function that gets called from SDL whenever it wants you to fill up the audio buffer with samples. And then samples is the size of a buffer in what's called sample frame size, which means this isn't a size in bytes, this is a size that correlates to how many samples are in the buffer. And samples mean, for instance, I'm using 16 bits per sample at stereo. So my buff size, say I wanted 1,024 of those, or let's keep it simple, 512. If I wanted 512 samples, so we're pretending buff size is 512. That means in byte size I have 512 times 2, because 2 bytes in 16 bits, times another 2 because I'm in stereo, which gives us a total of 2,048, right? Or is it 4,096? I don't remember. 512 times 2 equals 1,024 times 2 equals 2,048. But I feel like I made a mistake because I think it should be 4,096. Must have made a mistake. No, I'm correct. I was thinking I made a mistake because earlier today I was working with the 1,024 for the buff size, which obviously times 2 would be 4,096. So that's where I was getting that mindset from. But I'm definitely not the best guy to learn the basics of this stuff. If you want to learn, you need to learn about, you just see, the thing about SDL, the callback function, is that it's very low level, and some people arrive into learning about this stuff and they're not really ready for it. They don't get why they need this SDL callback, and they don't get samples. They just want to play their music, and for that I recommend SDL Mixer. I've used it before and it's a lot easier. You don't have to worry about this low-level stuff and understanding how samples work and waves and all that stuff. But it's really useful if that's where you're at and you need this type of functionality. And it's nice because it all happens in a thread. You don't got to worry about it. But you use your best judgment. So, continuing, this is what happens. So, getting back to how this relates to my sdl2 audio devices and opening them up, basically, let's see here. Oh, I'm exporting some videos that they just finished exporting. So my app's a little more advanced in the fact that what happened by now in the code is that I've already looked up a configuration file, and I'll show it to you. There's this preferences.ini file with an audio out dev variable that I've embedded in here, and then this is my device name. So what's already happened is that got loaded into my application into this variable. So what happens is it's a char star, and I'm simplifying that long ass name into audio out device variable here. So right now, audio out device will actually have the text Soundflower 2 channel, which is this is actually the full title of my device. I'm not going to teach you yet how to, have a configuration file, but maybe I will, down the line in another video. If audio out dev, so basically what I'm checking here is, does this string actually have contents that I can work with? Or is it, because if it doesn't exist, if it's null, then we're gonna have to do something else. Actually, what I end up doing down here, if this isn't a pre-configured setting, I just open up the first audio device found. Because I mean, what else are you gonna do? Later down in the line, there's gonna be a GUI options menu where you can specify exactly what you want in the app, not just in a preferences file. and that'll automatically get written to a preferences file when we exit the app. Yeah. I was dabbling in the idea of maybe if the preferences should be written before the app exits, but I'm thinking at app exit time. Although then it introduces a slight risk of, if the app incurs any sort of issue, we've got to make sure that it writes those preferences no matter what. But I think we just put that in the destructor and it'll be all good. Anyways, I'm getting ahead of us. I'm thinking about the future here, and I'm just trying to teach you guys about how do we open up this device. So basically, let's go with the idea that we had a preference thing, right? Basically, this is more geared towards working with preferences files than it is about actual audio devices and opening them. But we're going to go through it together anyway, because I think it'll just help you get in that mindset of getting towards having a preferences file. Basically, I want to make sure that my preferences in here, I want to make sure that this supposed device name is actually a valid device. And how I do that is I basically go through all the devices by using my the variable how many that we filled up earlier, and I'm gonna do string comparisons with each one until I find a match. If I find a match, then I say match equals true, and then at that point I should break, because we don't need to loop any longer. And then if there wasn't a match, I'm gonna say, all right, well then we'll just make this audio out device be the first output device in our list of all of them, because we don't really have anything to go by, so we'll just use the first one in that list. So by this point where my cursor is, audio out device is either the one from our settings file, or it's just the first device in our list of audio out devices. So now that I have a quote-unquote selected audio out device, I'm actually gonna set that in a variable here so that we can always know what was our result of all this searching for a proper audio out device. So I call it selected audio out device, and I set it here. Now at this point we're about to open up the device, and this is where our device ID comes from, because we're going to call an SDL function open audio device. We're going to give it the string of the audio device we want to open, and then we're going to say it's a playback device, which this is just a 0. Then we're going to give it that audio spec that we created up here. We're going to give it the address of it, and we're going to give it the address of the have one that's going to get filled up. And there's a 0 here at the end, which I don't recall what it is, so I'm going to look at it. Like I said, the wiki is so useful. I have to find out how to download this thing, keep it offline version. But anyway, this last thing is allowed changes. So basically, we're gonna make sure we. So allowed changes allows you to specify things that are allowed to be changed in the audio spec, and a 0 would mean none, I think. See, allowed changes. So you need to read up on this. I just read it. Like for instance, I'm gonna read it. We should read this together. If you ask for a float32 audio format, but the sound card only supports N16, SDL will set the hardware to N16. But wait, if you had set SDL audio allow format change, SDL will change the format in the obtained structure, which is like the have thing we got going on. If that flag was not set, SDL will prepare to convert your callback's float32 audio to N16 before feeding it to hardware, and will keep the originally requested format in the attained structure. That's a very interesting situation. If your application can only handle one specific data format past a 0, and let SDL transparently handle any differences, And that's exactly what I've done here. So, I mean, they give you an easy way out with the 0 there. But yeah, you can manually support for having like different settings, and you can have it all being handled manually by your app. So now, then we get a device ID, and we can just look at this, make sure returns a device ID that's greater than 0. By the way, this is important with compatibility with SDL 1.2. This will never return a 1, since SDL reserves ID for the legacy open audio function. Now, I should really be checking that this is greater than 0, and I do. Thank God. Yeah, if it's not greater than 0, it should really be less than or equal to 0, right? Actually, I think the audio ID is like is an unsigned value, so it would never be less. Turns out, yeah, we got it right. Call SDL get error for more information. We're doing it right. I suggest you do the same. And then I just check if the have structure, and I wanted to see if anything changed. I didn't really make these proper statements though. They were the same here. Look at that. It's awful. We didn't get. This should, you would probably want to be a little more specific. I'm going to try to change this right now. I'm going to say, let's be a little more proper here. I think something more like, I have a special macro debug log. I'm not going to get into that, but I have some music playing. I want to change. Hey, wait, that was weird. Listen to Super Mario RPG. Nice. So, yeah, I wanted to be a little more specific with this stuff. So let me just go ahead and make these debug log statements. Whoops. There's a lot of ways you can do a find and replace, but this is one way I do it. I'm just holding down the command key to do that. We didn't get, let's see. What I really want to do is tab here. I'm thinking about I'm going to redo this whole friggin' thing. Whoops. Good enough. Let's see, I want to say it shouldn't be format for all of them. Why did I do format twice there? Must have made a mistake. Better look at the audio spec. These channels. I did format, frequency. Do channels down here though, and samples. I don't think we have to worry about any of the other ones. Yeah, alright, so I'll just delete that duplicate. These are all like int, uint-ish types, so I'll just put %d for all these. I'm interested in seeing it work, so. Opening audio devices on flower. Yeah, and of course nothing gets outputted because we got an exact match. Hey, did you notice that? That options window? Why did it show? When I closed the window, it showed? Why? Alright, well I'm trying not to get too distracted, but a hidden window presented itself briefly, and it should always be hidden. Strange. Yeah, it shows itself really briefly. Interesting. I'll look that up later. Alright, let's finish this up. Where were we at? We opened up the device, right? So one thing that's different is that we're not quite there yet. Let me hold that thought. Well, now that we have the device opened, we're eventually going to want to start it. You know, like actually start the thing to run. And what we do that to do that, we need to call sdl pause audio device with the device ID that we got, and then a value here that will signify 0 to play or 1 to pause. And we're just going to go ahead and verify that. Pause audio device. Yeah, non-zero to pause, 0 to unpause. And that's essentially, oh, then SDL close audio device, which once again takes an ID. With all of those things, you're basically rocking with a more universal. Also, if you use the lock, if you use lock audio and unlock audio, you just do the same thing with the audio device ID, but use lock audio device and unlock audio device functions. But everything I've just told you, that's pretty much everything there to get going on a more universal audio devices in SDL2. So thanks for watching my video. I hope you enjoyed it. I don't know if I suck at making these videos or not, because it's all in the context of SNES Tracker. I'm not just making tutorials, like concentrated tutorials. It's just more like I have this development blog going on, and I realize I've made some things that might be helpful, so I go ahead and I try to move my butt to document it. So we didn't talk about saving the profile preferences thing, but you can learn that somewhere else. I don't think I'm going to do that. Okay? Okay, thanks for watching. Bye-bye.